This is a teaching video for Introduction to Statistical Testing, which is number 23 on your specification for research methods in AS level psychology. So we're going to look at the sign test. And first of all, we're going to do a very quick recap on descriptive statistics. So we've already done a lesson on this, and descriptive statistics are used on a data set. You would do an investigation, and then after the investigation we would have a data set, and we would want to find the measure of central tendency of that data set, so like the midpoint, and also we'd look at measures of dispersion, so how spread out is that data set. And so descriptive statistics are pretty good because it means that we can see patterns of behaviour, we might be able to see a clear difference, or we might be able to see an association if it was a correlation. But with descriptive statistics, it only takes us so far, because just because we can describe the data set, it doesn't mean to say whether that investigation has actually found any kind of difference or association. Before the way that we can find out whether data is significant is by doing inferential statistics, and that's what this lesson is about. It's just an introduction, and we're going to look at the sign test. But inferential statistics find out whether the results from the investigation are significant. If results are significant, then we can infer the results to the rest of the population. So very quickly, a quick example, supposing we did an investigation to see whether using a mobile phone in a driving simulator caused people to make more driving errors. And we do the investigation, all the participants go into a driving simulator, they do the same course, but half of them have a mobile phone, half of them don't. And at the end of the investigation, we can see that more people made more driving errors when using a phone than when they weren't. But we don't know, we can't infer that using a mobile phone will make you make more errors and therefore more likely to have an accident, unless we do the inferential statistics. The data set can show us a difference that, say, 16 people, there were 16 errors made with a mobile phone and only 12 errors made without. But is that difference actually significant? And that's why we do inferential statistics. We want to find out whether the data in the investigation, whether that difference or association is significant. So, just going to read this out, and I want you to read along with it and take this in, because sometimes in the exam they just ask you the purpose of inferential stats testing. So researchers use statistical tests to determine the likelihood that the effect or the difference or the relationship that they have found in the investigation has occurred due to chance. Inferential statistics determines whether the data from an investigation is significant. This means we do an inferential statistical test on the data to find out whether the results of our experiment or any investigation are due to chance. If they are not due to chance, the results are significant. So hopefully by the end of this teaching video, you will be able to come back to this and be able to explain what that means. Okay, so any investigation always starts with a hypothesis, and hypotheses always come in pairs. So if the data is significant in our investigation, we can accept our alternative hypothesis. If it's not significant, we must accept the null hypothesis. So researchers always start with the null hypothesis. All sciences will do this. And the null hypothesis states there will be no difference or association found in an investigation. And we start with the null because we want to disprove the null. So an alternative hypothesis says that an investigation will find a difference or an association, and the alternative hypothesis can either be directional or non-directional. It's called the alternative because it's the alternative hypothesis to the null. So you always start with the null, and there's one null hypothesis saying there will be no difference or there'll be no association. And then the hypotheses always come in pairs. Alongside the null will be the alternative, which is the alternative to the null, and that alternative hypothesis says yes, something is going to happen, and we can either write from that a directional or a non-directional hypothesis, but both of those are referred to as the alternative. So a bit more jargon for you when it comes to statistics. Blimey, I'm going to struggle saying that. So for some reason, in statistics, when we talk about a directional hypothesis, which is an H1, so the null hypothesis is H0, the alternative is always called H1. If it's a directional hypothesis that you've written, then we called that a one-tailed hypothesis. And we use a one-tailed test when there's been previous research. And if you look at that cat, he's got one tail and we know exactly what direction he's moving in. Non-directional hypotheses, also an H1 because it's the alternative to the null. A non-directional hypothesis is called a two-tailed hypothesis, and it's used when there is no previous research. And if you look at that bizarre cat there, it's got two tails and we have no idea which direction it's going. So directional hypotheses are called one-tailed and non-directional hypotheses are called two-tailed. So there's lots of different statistical tests, and when you're in year 2, you will be learning about 8 of them, you lucky things. But in the first year, in year 1, we only need to know about one statistical test, and it's called the sign test. The 3 reasons we select the sign test are important to know because that could come up in the exam. They might ask you what, like a straight question, what are the 3 reasons that we select the sign test, or they might ask you a harder question, such as name 1 or 2 reasons we select the sign test and refer to the stimulus, but we'll cover that a bit later. So the 3 reasons we select the sign test are, the first is that we look at the type of data. So far when you've been learning about data, you've learned about quantitative and qualitative and primary and secondary data, but when we're talking about in statistics, when we refer to the type of data, then it's got another meaning, and it means that the data can be one of 3 things. It can either be nominal, in fact 4 things, nominal data, ordinal data, interval/ratio data. Don't worry about the other things at the moment, we'll do that in year 2. What you need to know is that the sign test uses nominal data, and if you're a French speaker you will see the first part of that word nom, which means name in French, and nominal data means that it's named categories of data. So, for example, this is a stimulus about an experiment that was in a prison where they reduced the temperature of the prison to see if it would make a difference on the number of aggressive acts that were carried out. They thought that a higher temperature would make prisoners more aggressive. So they changed the temperature in the prison, and you can see the data there. You can see that there were, it says number of prisoners, 17 prisoners. The number of aggressive acts reduced after the temperature was lowered. 1 prisoner, the number of aggressive acts increased when the temperature was lowered, and then 2 prisoners, the number of aggressive acts stayed the same. But where you can see there's 2 red circles around those categories, these are the categories. So the sign test uses named data, and that is the most basic level of data. You'll learn in year 2 that ordinal data is more sophisticated and interval ratio is more sophisticated again. But nominal data just means that we have named categories of data, and that's one of the reasons that we use the sign test. So the categories here are number of aggressive acts reduced or number of aggressive acts increased. Those are our 2 categories. Oh, it won't let me go back. Okay, it won't let me go back to tell you about the other reasons we select the sign test. So if you're watching this video, you should be able to just go back quickly and look at it. But so the first reason is it's nominal data. The second reason is we look at the research method. So when we talk about research methods, we're saying how do we investigate? And we could investigate by doing an experiment, a correlation, an observation, a meta-analysis, etc. And so the sign test will always use an experiment, and that is, so the research method has to be an experiment, and we call that a test of difference because we're looking at the differences between the conditions of the IV. The third reason we select the sign test is the experimental design. So we use the sign test when it's been a repeated measures design or a matched pairs design. And repeated measures means that it's the same people doing both conditions of the IV. And in a matched pairs design, although you've got different people doing different conditions of the IV, they're so similar because we've matched them on so many categories like their, I don't know, their age, gender, religion, IQ, sexuality, etc., etc. Those people are so similar that the people in the different conditions of the IV, we imagine that they're almost like the same person. So we use the sign test those three conditions are that it has to be nominal data, which are those named categories. It has to be an experiment, which we call a test of difference, and then the experimental design has to be either repeated measures or matched pairs design. So if you were in the lesson for this, then you would have taken part in the telepathy experiment, because we did an investigation in class to find out whether our class was telepathic. And if you look at this picture here, these are called xenocards, and xenocards have 5 designs, you can see there, and there are 5 of each, so 5 5s are 25. So there are 25 xenocards in a pack. They don't come in a big long line, they come as individual cards and they get all mixed up. And then the telepathy experiment is where one person will try and transmit the message of which card they're looking at to the other person, and the other person has to try and identify what it is. It's not guesswork, it's telepathy. So for example, I'm going to look at one of those cards now. I'm going to start transmitting that message by thinking really hard about it and looking at it. And the card I was looking at was the red cross. And some of you might be thinking, oh, that's the one I was looking at, and some of you wouldn't. If you were one of the people who was like, I was looking at that, I knew that's what she was thinking, maybe you're telepathic, maybe you're not. And we'll do an experiment. We did an experiment in class, and you could do it where we use all 25 cards and see how many you can correctly identify. And then we did it on the whole class to generate a data set. So when you do an investigation, you have to create your pairs of hypotheses. So our alternative hypothesis was that psychology students will correctly identify more than 5 xenocards each, and the reason you had to identify more than 5 was because you could have just said red cross the entire time and got 5 out of 25. So if you can identify more than 5, that indicates a telepathic ability. The null hypothesis is saying that telepathy doesn't exist and would say psychology students will not correctly identify more than 5 xenocards each. So we start with those hypotheses and we come back to those right at the end. At the end of the investigation, we're going to reject one of those hypotheses and we're going to accept another one. So the telepathy experiment was, I explained a little bit about it, and it was following previous research that some people had ESP. So because it was following previous research, we had to select the directional hypothesis, which we call a one-tailed hypothesis. And then we all carried out the experiment in class. So the people individually, so in pairs, people tried to transmit the message to each other. And so they ended up with 25 marks that would either be a plus or a minus. So if the person got the card right, they would put a plus, and if they got it wrong, they would get a minus. So you'd end up with 25 scores in that table on the right hand side, some of them pluses, some of them minuses, whether they got the card correct or not. So step 1 was to write the hypotheses and do the investigation. Step 2 is to record the data and work out the sign. So each participant added up their own pluses and minuses and recorded the sign. And if they got a plus, then, so if they got over 5, if they got 6 or more, then that first person would get a plus. If they got under 6, they got 5 or under, they would get a minus. So have a look at this table and you can see there were 15 participants in class, and these are the results of their investigation. You can see that participant 1 got 8 xenocards correctly identified and 17 incorrectly identified. So because that person got more than 5, they get, the sign they get is a plus. The next participant got 10 correct and 15 incorrect, so again they got more than 5, so they get a plus, and so on all the way down. So each participant would add up their own pluses and minuses and then submit the data into this table. And if you look on the right hand side where it says the sign, the people who got more than 5 got a plus, the people who got less than 5 or less got a minus, and so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 people got a plus and 3 people got a minus. Step 3 is to find the calculated value of S. So each statistical test has a symbol, and the sign test is really easy because the symbol is just S for sign test. It's not always the way. Things like chi-squared, the sign is x squared, which is a bit annoying. But the sign test is dead simple. The symbol for it is S, and we have to calculate the value of S from our data set. So to calculate the value of S, it sounds like whenever we say make a calculation, some people freak out going, I can't do maths, it's really hard. This is the easiest bit of maths you will ever do, because all you have to do is add up all of the pluses on the previous table, and we know that there were 12 pluses. You add up all the minuses, and we know there were 3. And then all you do is select the smaller value. So we had 12 pluses and 3 minuses, and we will select the value of the least frequent sign. So the minus was the least frequent. So the calculated value of S is S equals 3. That's it. You don't have to do anything else. You add up the pluses, there were 12. You add up the minuses, there were 3, and then you just go for the smaller number. It's really simple. Don't try and start taking the 3 away from the 12 or anything. That's way too advanced, and we don't need to do that. You just add up the pluses, add up the minuses, and select the least frequent sign. So our calculated value of S is S equals 3. Step 4 is that we have to find the critical value of S. So the critical value of S will always be in a table that doesn't change. Years ago, statisticians who were very, very clever made critical values tables for loads of different statistical tests. And what it means is that we're going to compare our calculated value of S to the critical value of S in order to find out whether the data is significant. So to find the critical value of S, now this is something that you might be asked to do in the exam. You might have to find the critical value of S, and they'll give you a critical values table. They won't give you a huge one, they won't give you one this big, they'll give you a small section of a critical values table. And to find the critical value of S, you need to have your critical values table, which is there, and you need to know your N value. So if you look there, you can see it says N, and the N value is the total number of scores, including any 0 values. So what that means is, in our experiment, we had 15 participants, and everybody got either a plus or a minus because there were 25 cards, and so you couldn't get equal amounts of both. So if you got 10 correct, that meant you got 15 incorrect. And if you got 12 correct, you got 13 incorrect, but you could never have equal numbers of things that were correct and incorrect. So if there were only 24 cards, you might have got 12 correct and 12 incorrect. And if that was the case, if you got the same values, then you would not get a plus or a minus, you get a 0 score, and you kick those 0 scores out of the investigation. So for us, there were no 0 scores, and we know that there were 15 participants, which means we had 15 scores. So N equals 15. So that's our first starting point. The next thing you need to do is think about whether you used a one-tailed test or a two-tailed test. So we used a one-tailed test, which means directional hypothesis, because there had been previous research. So then you ignore everything about the bit underneath it that says about two-tailed test. The next thing you need to do is identify the probability level, and in psychology our go-to probability level is P is less than 0.05. Unless they tell you otherwise, that's where you go. So you can see here the 0.05 level. So that then gives you all of the information you need to select the critical value of S. So you can see that S equals 3 because you're in the right column, the 0.05 column. We've gone for a one-tailed test and N is 15. So our critical value of S is S equals 3. And if you read on the left-hand side, the last paragraph, it says the calculated value of S must be equal to or less than the critical value in this table for significance to be shown. So that means that our calculated value has to be the same or less than that critical value. So we know that it is because our calculated value is S equals 3 and our critical value is S equals 3, which means that our results are significant. This was our data from before, so just to reiterate that there were no 0 scores, and sometimes though you do get 0 scores. So this table here is just to show you how you might get 0 scores. So there was an experiment where people gave their happiness score out of 10 before doing mindfulness and their happiness score out of 10 after doing mindfulness, same people, and you can see the first participant was 4 out of 10 before and 4 out of 10 after, so they got a 0 score. The next person was 2 out of 10 to start with and 8 out of 10 after, so they got a plus because they were happier after. Participant 5 was a 10 to start with, but obviously didn't like mindfulness, was a 2 after, they got a minus. So this table is just to show you how you might get 0 scores. And there were 10 participants, but there were 1, 2, 3, 4 0 scores. So your n value would be 10 participants minus the 0 values. So it would be your n value would be n equals 6 in that case. Anyway, back to our investigation. So I mentioned there about probability and that our go-to probability level is p is less than 0.05 or p is less than or equal to 0.05. And this lady here is called Carol. She's dead clever. She's a statistician and she likes to explain about probability. So Carol, take it away. She's saying, imagine you find the data is significant, which is what we have found. But what does the 0.05 mean? And this is really important. Sometimes you get asked about probability in the exam, like what is it? What does it mean? So p is less than 0.05 means that there is a 5% probability that our results are due to chance. And I'll say that again, and it's really important that you write down this sentence. There is a 5% probability that our results are due to chance. So that means that we've done our investigation, we found out that our class has telepathic ability because our results are significant, but there's a 5% probability the results are due to chance, which means that in science we accept that there might be a margin of error, that it might just all be coincidence and that actually our results aren't true. But the 0.05 level of probability is what we go to in psychology, and we're okay with that. This really pickled my head when I first started learning about statistics about 100 years ago, because I was like, well, surely something's significant or it's not, but I didn't really understand the features of science. The features of science so that we will do an investigation, we will see if our results are significant, and if they are, there is always this tiny possibility that actually the results aren't significant. And that's why scientists will replicate experiments and repeat experiments over and over and over again, because the more times you can replicate something, an experiment, like repeat it with the same results, then there's a higher chance that yes, your hypothesis is correct, like in our case, that yes, our students are telepathic. So probability means that although our results are significant, we accept that there might be there's a probability that the results may be due to chance. And in psychology, the 0.05 level is acceptable for us. So if the results of the stats test are significant at the p is less than 0.05 level, then we can be 95% certain that the data from our investigation is significant, and that means we can infer the results to the rest of the target population. Just a quickie about the symbols that you might be shown in the exam. So in the exam, they might express the p-value as either p is less than or equal to 0.05, p is less than 0.05, p is equal to 0.05, and they might even just put 0.05. So it all means exactly the same thing. But I put there, what would it mean if they put p is greater than 0.05? And that means there's a greater than 5% probability the results are due to chance. And in that case, we would say our results are not significant because we're not happy that there's a greater than a 5% probability. It's got to be a less than 5% probability the results are due to chance. So there are other probability levels on the table. So what does p is less than 0.01 mean? And so you'd need to say it means there is a 1% probability the results are due to chance. The second question, p is less than 0.10, is that there is a 10% probability the results are due to chance. P is less than 0.02, that means there is a 2% probability the results are due to chance. And in the table that you get given in the exam, it might have all of those values. And unless it tells you otherwise, you just go straight for the 0.05 because that is the one that we go to unless we're told not to. Okay, so back to our investigation. Our results. We know that our n value, the number of scores, was 15. Our calculated value of s is s equals 3. For a one-tailed test, the critical value of s is s equals 3. Are our results significant? Is the calculated value of s the same as or less than the critical value of s? And the answer is yes, our results are significant. So do you accept the H1 or the H0? Remember, H1 stands for the alternative hypothesis and the H0 stands for null. And so that means we can accept our H1 and we can reject the null hypothesis. So the hypothesis is psychology students will correctly identify more than 5 xenocards each. That was our hypothesis, our prediction. And what that means in our investigation is that our class has telepathic ability. We did do this experiment in class, and I do this experiment every year, and every single year the results are that the students are not telepathic. But this year was super weird, and the results were that the class was telepathic. People were literally getting the highest correct identification of xenocards I've ever seen. So maybe there's something about this 2022 cohort that is telepathic. Okay. So we know all that information, and now we need to report the significance. And I've put in the top there in the blue bit, do RM19. So if you're one of my students, you can go on the Files tab on MS Teams, go to the Research Methods folder and find RM19, because that is a handout that allows you to consolidate your knowledge and practice reporting the sign test and practice calculating the value of S, calculating the value of N, etc., and the critical value. So it'll give you tons of practice that you need. So if you're one of my students, just go on MS Teams and get that handout. If you're not one of my students, then you can, I'll put a link in the description below where you can click on the link to buy the resource. So when you report the significance, you have to state it in the same way. They want loads of information and it's really irritating. So the first thing you say before anything is whether the results are significant or not. Make it easy for the examiner. Write it in big letters, it is significant or it is not significant. The next thing you do is state the calculated value of S and say whether it's higher or lower than the critical value of S. Then you tell the examiner the N value, the P value, and you say whether it was a 1 or 2 tailed test. So at the bottom of this slide, you can see it says the results are significant. The calculated value of S equals 2 is less than the critical value of S equals 3, where N is 15. P is less than 0.05 for a 1-tailed test. That S equals 2. So I think in our experiment in class, there was the S, it was even lower. There was even more telepathic ability. Anyway, so you always report it in the same way. And if you go onto RM at 19, then you'll have loads of practice of doing that. And I've written it as a template at the top of the handout. So if you get stuck, you can just keep referring back to that until you get in the swing of it. So the very final thing, and I wouldn't worry about this too much, is whether the results are in the right direction. So if the results are significant, which ours were, and if the hypothesis is directional, which it was, we have to check that the result is in the expected direction. In this case, we expect people to be telepathic due to previous research, so we should therefore have more pluses than minuses. And if you think back, we had 12 pluses, 3 minuses, and so that's fine. That means that people are telepathic. If it had been the other way around and we'd had 12 minuses and 3 pluses, the results would have looked significant, but what that really means is everyone who got the minus got less than 5 xenocards correct, and so that means that they're definitely, absolutely 100% not telepathic. So you just have to check that the results are in the right direction. I don't know whether they'd really put anything on the exam about that. I've never seen it before, but it's just something to be aware of. And what I'd like you to do, if you have the cat book, the complete companion cat book, then take a look at page 218 and make some notes on probability. If you've got the green hair book, you'll just have to look it up what page it's on. Soz. So you might want to do a couple of other research methodology questions if you're really in the mood. In our experiment, what was our experimental design? What was our experimental method? What sample did we use? What's the name of the stats test that we use? Convert 5% to a decimal. What are the 6 BPS guidelines? And identify 2 ethical considerations for this experiment and say how you would deal with them. And if you need to check on ethics again, it's page 196 in the complete companion. When you're thinking about ethical considerations for this experiment, you can always go with things like right to withdraw, because that's, you know, you could certainly gain marks for talking about that. But think about anybody who might not want to do a telepathic experiment. So think about anybody who might find it damaging, or it might be against their religion or anything like that, because this experiment would not be suitable for some cultures or religions who don't agree with messing about with telepathy and stuff, because they think that it's not in line with their belief system. Okay, so there are some apply your knowledge questions, so you could pause the video and have a go at this question. That's from the textbook, the Complete Companion textbook, which is excellent for the exam. And there's another stimulus here. You could have a look at this, pause the video, read this stimulus and work out your n value. We'll have a read of that, and then look at the data to work out your calculated value of S and your n value. The rest of the questions and stuff on that are on RM19. So check MS Teams for any directed study, and if you have any questions, then please get in touch. If you're one of my students, I recommend that you do the Specimen past paper on research methods, the unofficial ones that I've made. The first two are they contain questions on the sign test. So go on MS Teams, look under the Files tab, go to Specimen past papers, and then click on the folder that says unofficial past papers for research methods AS level. And the first two of those have got questions on the sign test, so you could really practice your knowledge on those. Okay, it's time to go.